welcome back to the Minecraft tutorial. This is going to be the 8th part. In this part we're going to be talking about loading our level, and then we're going to, if there's enough time, which I think there will be, we're going to be adding different biomes. Although it won't be visible yet, the biomes, but I'll show you kind of an overview of what it will look like. So let's get into it. We're going to start off by opening the blueprints, and we're looking at our game mode and our chunk today. So most of the work is going to be in the game mode because that's where we're going to be loading our different assets, but some of it is going to take place outside in the actual chunk, but I'll get to that in a second because first I'm going to explain why we don't just swap these values out here and say, well, we just generate it like that. We can make it bigger. So I'm actually going to do that first, and we're going to see why we can't actually do this. I'm going to put -5 and 5, and the same thing on the X. So just that we have a 5 by or 10 by 10 grid here, or 11 actually to be fair, because 0 as well. Where it's just going to spawn them, and it's going to make the location correctly because our chunk handles that. And what we want to do is we're going to simply play, and this is what it looks like. Currently now it is generating. But the problem is right now, if we show for instance the FPS, and actually the player is actually... So as you can see, this is what happens. We actually get a proper generation, no problem, but it's very, very, very slow. And currently right now, the reason we see all the grass and not the rest is because the grass is preloaded before we actually show all the other actors, because of how we set up our get data assets. So right now, what's happening is it's iterating through all the different ticks in all the different objects, and that is extremely heavy on, well, the PC. So it doesn't just look laggy for you guys because of the recording, it is quite literally extremely, extremely slow. And so that's kind of one of the main issues with this system at the end of the day. So if we want to actually test it, we need to make it shorter. And the only way to do that is, well, to have less, sadly, because no matter how we work, we're going to get this infinite loop. That's the major issue. We can't actually do anything about it because in and of itself, we have to generate all these chunks. We have to do this for loop at some point because we need those coordinates and we need to place them at those coordinates. So we could do a list, but at the end of the day, a list is the same thing. We would have to do a for each loop through that list. So the problem would be the exact same. So what we have to do is very similar to what we did in the chunk, where instead of loading this in a for loop, we put it into a tick. And so that's what we're going to have to do here as well. But we're going to make it slightly different. So what we'll do is we're going to go through this list here on each chunk, and once a chunk is finished, it will load the next one. So what we'll do is here, we'll try to load the next one. Now, just like we did here, we need to have is loading because we're going to treat it differently. Because if the player were to experience the lag I just showed right now, when he's actually playing, that's not something we can actually have. So we want to limit that. So we're going to say if we're loading the map, meaning the player isn't spawned yet, then we're just going to do it quicker. Even though we'll have a bit of lag, that's fine. So we're going to actually have to make a function for this location. So we'll just go here and we'll make it a custom event. We will say custom event CE, and we'll say load chunk. Now, this doesn't take an input, nothing there. We just want to call it here, load chunk. Actually, sorry, we can't do it like that. We need a reference here, load chunk. There we go. So with this, we now have our load chunk that gets called after we've finished loading the actual chunk. It will load the next one. So instead of this, we just need to now call our load chunk right here. Just like that. But obviously that alone isn't going to do anything. We now need to also take this into account. So to get this to work, the first thing we need is we actually need to make a variable, because we need to know where we currently are in the process, because we need to have a maximum amount of distance we can traverse. So for that, we're going to make a new variable of type vector, which is going to be called loading progress. And this is only going to be used in the actual loading of the level. So this will be a vector right here. And we're going to set it here manually, because what we're going to do is we are going to set it to what we'll be using here, new variable, which is going to be called render distance. And I'm not sure if it works like the... I'm not sure if the Minecraft version of render distance works the same way as this, but what we're going to do is we're going to use it to tell it how much we want to load on spawn. So by default, we're going to put 3, just so that we don't sit here loading forever, because it won't have the crashes once we're done with this, but it will still take a certain amount of time. So here we're going to multiply this by -1, because we want to start our loading progress at a negative value. So we'll just do this right here. So that way X and Y are negative of it, and then we get to increment it as we go. Just move it a bit to the side. So now with this, our CE chunk, what we're going to do is we're going to start with a branch, just so we can check whether we are finished or not. So what we need is we need to know how far we've loaded relative to the end goal being the render distance. So we'll split this here, and we want to check if our X is inferior or equal to the render distance, and the same thing for the Y. That way we can check whether we need to stop or if we can keep going. So if both of these are inferior or equal, that means that we can still keep spawning. So very simply, we will grab our spawn here and we'll place it right here. So as long as this happens, we'll keep going. Now on false, we're going to make a very quick function. We'll fill it in later, but this is called finished or loaded will do. That means that we finished loading the map and we get to call it here, and this is where we're finally going to stop our character from falling into the, well, absolutely nowhere, because currently we have our player start just here, so the player just kind of falls off. So we're going to avoid that by having it removed, and we'll just tell it to spawn the player once it's ready. So let's go, and first let's start by loading the chunks. So now that we have our loading progress, we can multiply this by 1600. So I'll turn this into a float. We're just repeating the same process that we have right here. So 1600, plug that into the transform, and then obviously we take the coordinates and plug those into here. We also need to do something for later, although here we don't really use it. It's going to be necessary. What we want to do is we want to make sure we save this, because we need to know which chunks exist so that we don't constantly reload them in their entirety, because what we're going to do is we're just going to hide them once we start moving around the map. So to do that, what we'll do is we're going to save this in a map, and the map is going to take in the location, and it's going to say, it's going to take in the location as a key, and it's going to put a chunk as the value. So we're going to duplicate our loading progress, and we will call it map of chunks, or map of chunks, yeah, sorry. There we go. And so we want to turn this into a map, and on the integer here, we are going to set it to a chunk. So our actor right here. Now we just have a little bit of an error here. We just compile again and it will get rid of it. So here we want to say add, and we're going to add our loading progress and our return value. Just like this. But there's one last thing we need to do. Because this is a loop, in essence, it's just not with a for loop or anything. We need to increment this value. We need to modify that value. So what we need to do is we need to determine which one we need to increment. We need to increment X or Y. So to do that, we need to go and do a branch and determine whether we've already reached the end of X. And if that's the case, then we need to go and reset it and increment Y. So to do that, we want to get our load in progress, split it. And from the X, we will check if it is double equal to our render distance, because that's the limit, and we'll say -1 this time. If it is double equal to -1, that means we've reached the last point and we've placed the last point. And that way we can increment it because now we're at the end. So what we do is we then say a set for our progress right here. And what we'll do is we need to get another reference to it because it needs to be +1 on the Y. So we're going to say +1 on the Y. And actually, sorry, no, what we're going to do is we're going to split this. We do need to do -1. We just want to say -1, sorry, not -1, +1 on the Y. But for the X, we need to do what we did at the beginning. And that means we need to take this right here, the render distance times -1. Just like this. Plug that into the X. There we go. And here, we just want to put double equal, sorry. Now, on the other hand, if we don't want to do this, we simply want to increment the X. So what we do is the same as here, but we just plug in the X instead of the Y, and the Y needs to get plugged into itself so that we actually save its value and don't reset it back to 0. Z doesn't matter, obviously, because we don't care about the height here. So we can compile, and there we go. So now this, what it will do is it will go through each time and it will increment the loading progress until it reaches the end, and it will then call map loaded. So to finish things off, we can get that map loaded, or we can, to be fair, we can run a test first and see if this actually works. Yeah, okay, so to make sure that the player doesn't actually, because right now if we play, the player will still fall out of the map. So what we need to do first is we need to quickly modify our class default settings of our game mode and just tell it by default that we don't want a default pawn. If we remove that now and we go and play, the player will just sit here and won't be able to do anything. And so if we now do that, we can actually play, and we'll be able to see currently, as you can see, the FPS is low because it is generating the chunks. Now, if we do F8, we should be able to check, but it's going to be very slow. As you can see, it's generating correctly. And let's just focus it so we can see. So as you can see, it's generating the environment. So as I mentioned before, the reason we're seeing the foliage first is because, well, the foliage by default appears when we do our for each loop, but the actual blocks only appear once we're finished doing all of them. There we go. So it is finished loading, but as you can see, it takes a decent amount of time, but then we're back to 120 FPS, at least on my end. And it could be higher for you depending on your specs, obviously, but 120 FPS, it doesn't lag, everything's loaded. But the thing is, it does take some time to actually reach that point, and that's kind of what holds back the entire system in Blueprints, is that the loops just can't be fast enough because, sadly, unlike in C++, we don't have access to multi-threading, which could solve most of the issues that this project faces. Let's get back to now our map loaded, where we can actually see the player and have the player move around. What we want to do here is, now that we've loaded our map, we want to know where to spawn the player. Now we're just basically going to do a line trace above the location we want, and we're going to shoot it straight down and see, well, where can the player spawn. And the coordinates I'm going to use is block 8, block 8, so that we're in the first chunk. Usually you want to keep it between 0 and 16, that way you're always in the first initial block, that way you won't mess up how the generation works later. So what we're going to do is a line trace by channel. The coordinates, we're going to put them in manually. It's going to be 800, 800, and then I put about 10,000. So it's like 100 blocks up, but obviously if something can be 100 blocks up in yours, then you can't have that, it needs to be higher. So for the end, 800, 800 again, and 0, 0, because that's bedrock, nothing can be under that either way. Normally you shouldn't go that low, but for security reasons, just for safety, just in case, leave it at 0, that way you'll always hit something you're sure and the player can spawn. So with that, we're then going to break hit results. And this is once again another measure of security. And we're going to say impact point here, select. If we did hit something, so blocking hit, we use that. If not, we simply want to use trace end. That way the player will spawn at the end of it, because apparently we didn't hit anything there anyway. And then we want to say, well, spawn actor from class. And we're going to be looking for first person. So I believe it is first person character. Split the transform. Plug the vector in. And the last thing we need to do, just to make sure this functions correctly, is we need to inform the player the controller that it can actually connect to the player. So to do that, we want to say get player controller right here. And we will say set view target with blend. Just like this. And we'll just connect this to the new target. And that's going to change the camera, you could say, of the player that we're currently using. By default, the camera is 0, 0 right now because we don't have one. But once it's loaded now, it will say set it to the new one of the player that we just spawned. And that'll do it for spawning the player. So let's give it a try. We will press play. And I'm just going to fast forward this and I'll meet you guys once it's loaded. So now the player has actually spawned in normally. So if we have a look, he has. So now by default, you might not be able to actually move. And that's because there's something I forgot that we need to set up in the player character. And there's also another issue that I realized as well. And that is that by default, this is wrong. We need to add a slight offset for the actual player, because otherwise he will spawn in the ground. So we'll just put 100 extra, so it will be a slight drop. That way we're sure he's not stuck in the ground. And so what we need to change in the player character, which we can get to by browsing here to it, is we need to make sure that in its default settings, when we look for possess, we need to make sure that the auto possess pawn is actually enabled. And we're going to put player 0 because that's the basic player. And if we don't do that, the reason is because even though the camera swaps, it doesn't realize that the controller changes as well. So here we can actually auto-possess it right here. So let's compile. So we'll play. Once again, it's loading, so I'll join you once it's finished. There we go. So now we actually have our map. We can actually move around. Now, one thing that I noticed is I forgot last time is that currently we bump into the grass and we actually interact with it like this, which is not correct. It's not a problem, but we wouldn't want to do it like this. Normally we should only bump into the actual blocks itself. So as you can see, the map is fully loaded and we can see our cave down here, for instance, if we want to go explore that. And this is the basic part of all the generation. And next we're just going to be setting it up so that it loads the rest. So let's just very quickly make a small change for the foliage that we can actually walk through it. And that's really simple. We just want to go into blueprints, instant static mesh for foliage. And we want to open our class defaults if it's already the case. And what we're looking for is simply collision preset. And we're going to say overlap all by default. And this way, I believe, no, we want to put it custom, but we can do overlap all first. That way it's all overlapping. Same for that. So overlap all. But you might want to make it block for camera. That way we can still actually break it if we want by mining. Okay, so now we finally have our whole map generating. Now the next thing we want to do is we're going to be talking about adding the biomes. Now, before adding the biomes, we have a little issue. Currently in our assets, all we have is kind of grass blocks. So I added another quick PNG just for the sand so that we can make a sand block as well. That way we can test a desert biome without dead bush. That's the whole point of the dead bush, but I forgot the sand at the beginning. So I'm going to go and import that. You can do the same. There'll be a link down in the description, obviously. Let's just drag that in here. Now, as usual, we want to open it. We want to go down to our filter and put it to nearest. There we go. So now our sand is set up correctly. And what we'll do is we will make our data asset for it. So duplicate the stone one, call it sand, open it up, and we will swap this to sand, change the name as well to sand, and we will just copy, paste all of them so that we have all of them being sand. There we go. So now to get the biomes working, we're going to need a few extra functions. The first one of which is going to be in our GM, or in our game mode. So we don't need our first person character anymore. We're going to go back to event graph, and we actually need to do two little things. First, we can actually get rid of this. We don't need that anymore. And here we're going to need to use this again. And what we're going to use it for is we're going to get a stream, I think it's called, if I remember well. So what this is it's called a random stream, and what it is so that whenever in integers, whenever we try and, or floats, it's all the same, whenever we try and get a random value, you have multiple options. If we type random float here, for instance, we can do random float, which will choose any float between 0 and 1. We can do random float from stream, which is identical. It will choose between 0 and 1, but the difference is we actually get to give it a seed. And so we need to do that so that if ever we have any other random aspects that don't use the specific noise here, we actually have the same result if we use the same random seed. So what we need to do is we're going to move this to the side a bit, gives a bit of extra space, and we're going to get that random seed. We're going to create that. So what we want to do is we want to say stream, and we want to say set random stream seed. And so we want to plug this in right here. We're going to turn this obviously into a variable. So we're going to drag out from it. We're going to drag out from it, promote it to a variable, and we'll call it random stream. And we're going to be putting this to use straight away. And just actually plug that in here. It's a bit easier to read. And we're going to use it immediately for a function that is going to be very, very simple. It's going to tell us what biome we're using based on the chunk coordinates. So we're going to make a function for that in here, and we'll call it biome by location. And currently we don't have a means of identifying the biome, so that's what we're going to do here as well. We're going to need, in our structures we'll do this, we're going to need an enumerator. So in our blueprints, enumeration, we'll call this biome. And for the tutorial, I'm only going to do our current one, which is a forest, we'll call it, even though for now there aren't any trees. Forest. And the second one will be desert. So close that. That's all we need to do, nothing else. And with that, we can now actually return from this function, not that, return node, and we're looking to actually return that output. So this is going to be e_biome right here. And so now we're going to tell it what that is. So to determine the random biome, what we're going to do is we're going to do the same trick as we did for the ISM in here, where we're going to have a map first, and we're also going to create it if we don't have it. So the first thing is we need an input. And that input is going to be a vector. It's going to be coordinates. I'll also change the new parameter to return value. There we go. Move a bit to the side. There we go. So we'll start with the branch, but we're going to... So I'm kind of getting ahead of myself here. I completely forgot, but we do also need to make, obviously, a noise generator for this. But first, for now, let's just go ahead and... What we want to do is we want to break this. And we'll just, for now, use our mineral noise for a second, and we'll say get noise 2D, and obviously same as usual, X and Y, we plug them in like this. There we go. And what we'll do now is we will make our map, and what our map will do is very simple. It will take in this. We're going to do a bit different here. We're not actually going to use the coordinates to determine the map. We're actually going to use the result here, and we're going to say anything that has the same result can be used. It's going to be very similar, but that way, because we'll be using a Voronoi noise, it will be areas that instead of just one specific coordinate. So it'll be lighter when we search for it. So once again, this is a map. This is going to be biome map, or we can use the same name as before, map of biomes. There we go. And this time we want to turn this into a float. We'll turn the value into the e_biome. Like this, and now with it we can say find, and if it already exists, if our noise has already been found, then we can simply return the result here like this. Now on the other hand, if it doesn't exist, we need to actually create it, and so to create it we need to actually use a local variable. And the reason for that is because what we're going to do is we're going to get a random array from item from array, sorry, a random array item. And we need to make sure that we use the from stream, because if we don't use this, then we're going to get a random one, you could say completely random one, every time, no matter what the seed is. And we want to make sure that whenever we change the seed, when we have a specific seed, everything is the same. It's always the same no matter what happens. So for that, we need to use our random stream that we made at the beginning. And what we're going to plug in here is we're actually going to need to make our variable first, or wait, we can do it like this. There we go. So just plug this in for a second to the return value and say make array. And the array is simply going to be forest and desert here. So if you have any more, you add them here, and then we'll handle the rest after. So just plug this in here. And so we need to actually promote this to a variable, because how this works obviously is every time, how pure functions work, if you're not aware, every time this pin gets placed somewhere, it recalls the function. Meaning, if we plug this into our add here, because we're going to need to add it to that array obviously, then it will be different for the return value. So we need to promote this to a variable so that it only happens once. And this will be our temporary biome. There you go. And so this temporary biome is going to be added to our map. So add. There we go. And obviously we can plug in our noise here. And obviously the noise isn't a random thing, so it doesn't matter. We don't need to save it. And then we want to plug in our temporary, which has to be the variable. So like this. And then finally, we simply want to return. Just copy that. And we're going to return our variable right here. Now this whole function can actually be pure. We don't need it to have the execution pins. And that'll do it right here. Now, we need to change one last thing, and that's the mineral noise. We need to make a duplicate of it, which we should have done first, to be fair. It's a bit stupid on my part. And this will be our biome noise. And so this is going to go up here, so it's all at the same spot. And we will drag it on top of the mineral noise to replace it. Now, with that in mind, what we want to do is we need to actually make our biome noise. Because currently we have our noise for the terrain, we have our noise for the caves, we have our noise for the minerals, and we have our noise for the foliage. So what we want to add now is another one. So we'll just copy the whole thing for now, plug it in, and this is going to be right click. It's going to be changed to biome. And we're going to change this from our cubic currently to cellular. So just like with our, not our caves, our minerals, where we wanted it to be cellular, so that we have kind of like mineral veins, so we don't just have one point that kind of spreads out evenly. We want to have it have a more natural feel. So cellular, we're going to put the value to 0.07 here. We want it to be very low. And we're going to interp to quintic because we want it to be high quality again, or precise. And we want this to be down to 2. And I believe the rest is, and we want to change the cellular difference function to be natural, so it has a more natural feel to it. So compile, and now we have our biome by location. But the problem is, it doesn't really matter. We can't actually tell the difference. So what we're going to do to test it to see if it's working is we're going to use our good old testing cube here. And so for our testing cube, what we'll do is, before we just had this, what we'll do is we will now tell it to have a biome. And for that biome, we're going to, well, get our enumerator for the biome. Like this, we will make it exposed on spawn. And we don't actually need the data asset anymore, so we can actually, well, we'll leave that for now. It we might reuse it later, even though I don't think so. In the event graph, what we're going to do is we're going to get our biome here. We're going to switch on biome. And very simply, the biome by default should be forest. But what we're going to do is we're going to tell it what texture or what data asset to use, to be fair. So it's a good thing we did do this. We're going to set this to our grass block here. And if not on desert, we will set it to sand. And so with this, we can then use this here and set its actual material. So that way we use what we did before. plug this in. And so what we're going to do is inside of our game mode, instead of doing what we did here, we'll use our biome by location to set up the actual material. So what we'll do here is, because it's smaller, we're going to do a double for loop again. So grab one of those, grab two of these, reroute these just so we can make a, so let's just make a vector here and just convert these over. We'll make it much easier. And then what we'll do is plug in this here. Let's just move it down for a bit of space. So first index, we'll say minus 16, 16. Now here we can actually make it large because it doesn't really matter. 16 minus 16 again. And what we're going to do is we're going to say spawn actor from class. And this time the class is going to be our testing. So there we go. So now we can actually plug in our biome. And for the coordinates, we're going to reroute this. And we're going to say times 100 again. Now this time, because it's not chunks, we just want to see kind of a miniature view of what the chunk system will look like once it has its biome set up. Because it may not be visible because we don't have an infinite view. So we're just going to do this. Play. And there we go. So it has generated. It's just not visible. So now you can actually see what it would look like. And if you picture this, each individual cube here is an actual chunk. So it would be a lot bigger. But if, for instance, we tried to view it with the chunks, it would be very difficult. But this is the kind of feel you'll get. Obviously, there's only two different ones here. But if you start adding any kind of thing, any biome you can imagine in Minecraft, then it will start to be a bit better. And obviously, you can tweak the value right here. If you want to have it be bigger or smaller, then this is what you want to change. So, with that out of the way, now let's actually go and make it so we can actually see these biomes. So, obviously we might not be able to see, but we can just rerun the project until we get a desert or whatever. So for now, let's just delete this and just put this back to, well, actually no, we won't delete it. We'll just leave it here in case, that way you can check if it's functioning later if we need to. So we'll just reattach this so it loads our biomes. And so what we'll do is in our chunk here at the beginning, on event graph begin play, in addition to this, we will say get biome by location. And we already have our location right here with our chunk coordinates. So we will simply promote this to a variable, which we will be calling chunk biome. Chunk biome. There we go. So plug this in right here. Move it a bit to the side. There we go. So compile. So now we have our biome saved in the individual chunk. Now what's left to do is we need to modify our data asset by location again, so we actually take that into account. So a very simple thing we could do just to test if it's working is every time we have a grass block here, we can do a select to see if it is actually a sand block instead. So we can try that just to make sure, just see if it works. So we'll say select, and if it is a forest, we will say grass block. If not, we'll say sand. So we'll just copy this again right here. And obviously this won't work for the stone because the stone wouldn't change. We'll leave it as it is. And so let's try this. Now, by default, it might just be grass again because it's random. That may be the case, we don't know. So let's wait and see. So there we go. So now we have an actual distinction. We have some grass and we also have some sand. So obviously we won't have the trees. We're going to be modifying that in a second, but this is kind of what you would get. Now, same, obviously, you wouldn't have dirt under, you'd have sand. So let's get that as well. So now that we know it works, let's go ahead and make the modifications we need. The first thing we can do is we can start to set up this right here, our short grass. Now, one thing we can do is, depending on which biome we're looking at, we can say, well, we don't want to have it be 0.17. We want it to be a lot higher. We want it to be harder to have it appear. So what we'll do is we will say select, and we need to make sure that we do the bottom one here, because what we want to put in as a index is the biome. So if it's forest, we want it to be 0.17, but if it's a desert, we want it to be something like 0.7. So it's a lot less likely to happen, and I think even higher than this would be okay. But we still want to know that it works, so we'll let it be less. Now here, same thing, we can change this with a select, so we'll just copy this. And if it's forest, we want it to be short grass. If it's sand, we want it to be the bush, but we don't have the bush. Let's make the bush. So data assets, and we have short grass here, duplicate it, and this time it's going to be dead bush, I believe it's called. And so we can double click that, change the texture to our dead bush, and we don't need any color because by default it already has a color. So now, if we generate it, we will have a different likelihood of having a dead bush than we will of having short grass, and we'll also have a different appearance. So let's try that. We do have a desert, but we seem to have an issue with there being no dead bushes. So that probably means that the value is too high, but 0.4, let's give that a try. Also, there seems to be an issue with the cave system, and I'm not sure what it is. Okay, so I know why. So the reason is because for some reason I forgot to put it into world, so the cave network was identical for some reason across all the blocks, and I failed to notice that. So if you have the same situation as me where your cave is repeating the same pattern in every chunk, that's simply because you're telling it to repeat the same input pin, meaning it's going 0 to 16, 0 to 16, 0 to 16. It doesn't matter which chunk, it will repeat the same thing. So make sure you connect it via the to world. That way it will convert it from its current location to world. But I just remembered we also do need to divide it by 100 because we're looking at coordinates and not the actual block location. We need the block location because in world it does by 100 here. So just go back to this. Make sure you do it this way. And for some reason I did that, even though here we just need the actual Z. We don't need the world location. So that's just overkill for no reason. So let's try that again. We now have a more likelihood of encountering our... That's why. Also, I forgot to put the dead bush, which is kind of stupid. We get no bushes if we don't tell it to put bushes. So let's try that again. And our caves should also be fixed. Let's compile, save, and play. Now we still have an issue where underground it is still dirt, but we'll get to that in a second. Now our caves are generating properly, as they should. That's good. Okay, so there we go. So we do indeed have our dead bushes. They're appearing. There may be a few too many, but it's not a big problem. It's just fine if it's like this as well. So let's go ahead and close that. And next we need to do the last thing, which is make sure that we have sand below as well. So we're going to do the same trick here. If we want dirt below, then we don't want dirt, we want sand. If not, we just want to keep our dirt right here. Now, one other thing we can add here, one other distinction is here we add some extra height so that based on our noise, which only goes from 0 to 1, we add 65 so that it's a bit above the stone that we have. Now, if we want, we can also do our select here. Not that select. Wrong select entirely. If we want, we can also change it here so that this is still at 65 with the forest, but for instance for sand, we would want it to be something like 62. But one thing we can also do here is we want to make sure that this is actually clamped. Clamp our float here so that it never goes below 61. And maximum it can be, well, whatever it wants. We'll say 90, even though it should never go above that. That way what this will do is it will make sure that we don't have, as you may have noticed before, we had a bit of a stone patch in the grass, which was simply because it went below 60, so it just put stone instead. Here what's going to happen is our forest will be higher up than our actual desert. And let's get a try. Obviously if you want as well, and I'm not going to be covering this, but that's if you want to. If you want, you could also change the noise here and make it so that if it's grass, or if it's a biome for grass or a biome for sand, you can use a different noise. That's also entirely possible. You simply just put the select here as well and use a select for the noise. So let's check now if we have a different height and if we fix that stone layer. So there we go. So now we have our sand, which is slightly lower, although one of the problems is we kind of get this disconnect between the different biomes. But now we have two different heights, and we should never have our stone kind of area. It seems to have disappeared, so this does solve the issue. Here, obviously, you have a kind of hole because it's supposed to go down. It's just a normal area that you want to go down into. And I believe that'll do it for this part. I hope you enjoyed, and I will see you in the next part. I believe the next part is going to be on movement, because currently right now, the player can just kind of run off the map, and we don't really want that. So I will see you for that, and the next part, I'm not sure if I manage to solve the issue by then. It will also include adding trees, but if that doesn't happen to pass, then there'll be probably a extra part just for that, because I do want to get that solved. I'll see you then. Goodbye.